In the previous video, we learned about something called the common logarithm, abbreviated just by writing log, log. And the common logarithm is the inverse function of 10 to the x, which means if 10 to the 2 equals 100, that's exactly the same as writing the log of 100 equals 2. And if 10 to the negative 2 equals 0.01 or 1/100th, then the log of 1/100th equals negative 2, and so on. That's the common logarithm. But of course, we've done lots of exponential functions that are not 10 to the x. And so we may be interested in seeing what happens if it's not 10 to the x. So 10 to the x equals something that we'll just call y. That's exactly the same as writing the log, common logarithm, log of y is equal to x. Whatever this exponent is, that's what the logarithm equals. Whatever 10 to the exponent equals, that's what we're taking the logarithm of. The x and the y switch places, which makes sense because it's an inverse function. All right, so what if it's not 10 to the x? What if it's, for instance, 2 to the x? Well, this log only works for 10. If the base underneath your exponent is a 10, then we use the common logarithm. But in the same way that all of the x's that we put into our exponential function give us a y, so we should be able to reverse it, like we talked about in the last video, to find out what our input originally was. Well, that still works even if it was a 2 down here. So there's an inverse function, but we don't want to use the common logarithm because that's for tens. So we use a logarithm, and we say it's the log base 2. So the way we say this out loud is the log base 2 of y. And what that means is the base underneath our exponent here is a 2. So let's see how this works. 2 to the third equals 8. That's exactly the same as writing the log base 2 of 8 equals 3. And we should recognize that this little 2 down here, it's a subscript underneath logarithm. It's log and then a little 2 as a subscript, and the 8 is on the same level as the word log. Well, so what about something like 5 to the second equals 25? Well, if this was 2 to the third equals 8 and we called it log base 2, then this one is going to be the log base 5 of 25 is equal to 2. Whatever the base underneath the exponent is, that's the base that's written as a little subscript on the logarithm. Whatever the exponent was is what the logarithm is equal to, and what the exponential equaled, that's what we're taking the logarithm of. Because the output from the exponential function becomes the input into the logarithm, and vice versa. Well, so there's nothing magic about the numbers 10 or 2 or 5. This will work for literally any positive number here. We don't use 1 because 1 to any power is still 1, so it's kind of a trivial case that's not worth exploring. But if we've got 7 squared equals 49, that's the same as writing the log base 7 of 49 is equal to 2. and so on and so on. So we can have the log base any number we want down here. We could even say 1/2 to the -3 power. The negative says I'm going to flip this over, and the 3 says I'm going to cube it. So 1/2 flipped over is 2, cubed is 8. 1/2 to the -3 power is equal to 8. We could write the log base 1/2 of 8 is equal to -3. We can do the log base anything we want. Well, there's one more logarithm we should talk about, because one exponential that keeps coming up over and over again is e to the whatever power. E to the 1 is 2.718 with more decimals after it. Well, that would be the log base e of 2.718. The number that e equals is equal to 1. The base comes down here. What was the output from the exponential is what we're taking the logarithm of. And the 1 that was the exponent, that's our output on the logarithm. However, historically, the log base e gets its own special name. The log base e is called the natural logarithm. Natural logarithm is log base e. Because, remember, e is what we do when things are happening continuously, compounding continuously. Well, that's really what happens in nature. And so e is something that shows up a lot when we're talking about population growth or radioactive decay. Things that are always happening really deal with e. And since that's something that shows up a lot in nature, it's called the natural logarithm. However, the first people to talk about natural logarithm were French. And in French, I'm not going to try and spell it here because I don't remember how to spell the French, but it's logarithm naturel. Logarithm naturel. So the L, the logarithm, comes first, then the natural, the N, comes second. And so the special name for log base e is written as an L and an N. I'm using a cursive L here because if I write it like this, it kind of looks like maybe it's supposed to be 1N. So I write it with a cursive L. This is the natural logarithm, natural log of 2.718 is equal to 1. Natural log, ln, is the same thing as the log base e. It's just a special name. So the only two that have special names are the common log, which is the log base 10, and that one's written as just log. We don't put any number down here of whatever we're taking the logarithm of. The log base 10 of x. There's no number down there. If there's nothing there, it's a 10. The other one is the natural log, and that's the log base e, where e is that number 2.718 with all its decimal places, and that's written as an L and an N. ln, natural log. All the other ones don't get special names. They're just called log base whatever. Log base 4 of 16 is equal to 2, because 4 to the 2 power is 16. Log base 9 of 3 is equal to 1/2, because 9 to the 1/2 power is equal to 3, and so on and so on. Those are all the different logarithms. They're all inverse functions for exponential functions.